All right. Again, just real quick, flashing back. We talked about in the last video about the different words that we're going to use. Just to remind you, we have the word chord, which is going to define a line segment that's held completely within a circle. We're going to utilize the word secant, which is a line that cuts through a circle and will intersect that circle at 2 points. We're going to discuss the line tangent, which is a line that only intersects a circle once and will never go through the interior of the circle. We're also going to, and that's actually going to be the big thing that we're going to talk about today, because today's, this lesson is talking about lengths of line segments. And in these lengths of line segments, we are going to look at 3 situations. We are going to look at intersecting tangents, intersecting chords, and finally, intersecting secants. There is a whole bunch. They go through some proofs inside your novel, whatever that thing is called, the resource guide. And there's a lot of stuff that goes with that. But overall, there are 3 equations you have to have memorized. The first of them is the intersecting tangents. You can, tangents. Time to go home. Intersecting tangents. So there are going to be situations where I will draw a line tangent to my circle. There you go. There's a line tangent. And I will have another line tangent to my circle. And this is a situation where line L and line M are going to be tangent to the circle C. That seems like a good name for a circle. I don't want to name it circle C because that's going to get confusing later on. We can call it circle. Oh, wait, I guess I'll call it C. Why not? And I know that A is equal to 6. And I want to know how long segment B is here between the point of intersection and the other point. Tangents are super easy. The equation for the difference of line tangents is that A is equal to B. That's right, folks. If the distance between the intersecting point and that point and the point of intersection here, the intersecting point of the tangents and the intersecting point of the circle is 6, then this must also be 6 between those two. Yes, I realize it probably doesn't look like that. That's because I don't have a wonderful graphing thing. I am trying to do this by hand, and it's really hard, and I just don't really care about the artistic side. Also, that's a terrible spot for the tangent. The tangent should probably be up there. That's all I got. So if I know that I have 2 lines that are tangent, I've got that. Now let's look at some more interesting ones. Let's deal with chords first. Mainly because I know that if I have chords, I can't really screw it up. So chords, again, are going to be line segments that exist within the circle that are comprised, the endpoints are comprised of being out here. Now, if they're not intersecting chords and they simply come down to a single point, such as an inscribed angle, there's not much you can do about this. There's not a relationship that's going to really work with that, and that's because of how this relationship works. So there are essentially 4 line segments that exist here. There is an A, a B, a C, and a D line segment. And on a chord, I'm not going to go through the proof because I didn't take the time to really make sure that I knew the proof. But on a chord, if I'm dealing with line segments, I find out that the line segments AC, if I multiply that, A times C, that will equal my line segment B times D. Or rather, the 2 parts of my chord, when multiplied, will equal the 2 parts here. The most common way they're going to test that is they will tell you that you know that A is 3, C is 1, D is 6, so what on earth is B? And you would have to realize that 3 times 1 is equal to 6 times X or B or whatever, let's call it B. And I would realize that 3 over 6 is my B, which is 1/2, and I would get a final answer. And that's going to be the most common way for them to be able to ask that question. Other things they could give you, they could run it through the center of a circle, so you have radius, and you'd have to understand that the radii are equal to each other, which is really not a hard thing to do necessarily. There's a lot of things that will require you to be logical about it, but that is what they'll do with chords. The last but certainly not least is going to be the intersecting secants. These are by far the worst. So when I'm looking at secants, I'm looking again at 4 different segments. I'm looking at segment A and B. I'm also looking at segment C and D. When I'm looking at these and I'm looking at a secant, the equation for this turns out to be, you actually take the A and multiply it by the A plus B. So it's essentially, it's the outer segment here multiplied by the total distance of that secant from intersecting point to furthest point over here. And that is going to equal our C times C plus D. Again, taking this segment here and multiplying it by that entirety there. The questions that they're going to ask for this are going to be the exact same style questions that they're going to ask for the chords, where they might give you the A is, they might give you, oh, you know what, let's do it this way. They might tell you that the total length is 9 and that B is 7. And then they will tell you that C is equal to 3. And they want you to figure out what on earth is D. So in this particular problem, what I would have to realize is that I know what A is. A has to be 2 because 7 plus 2 is 9. So I would have 2 times 9 is equal to 3 times 3 plus D. So in this case, we'd have 18 is equal to 9 plus 3D, or actually, I don't know why I did it that way. I would have just divided by 3 here. 3 times 3 plus D. This is for my people not quite so keen on the algebra. Divide by 3, 6 is equal to 3 plus D. Therefore, D must equal 3 when I subtract 3 from both sides. And that is the type of question that they will ask you when you're talking about intersecting secants. That was an incredibly fast rundown. The big thing is realizing those equations. So again, I was like, oh man, those are angle measures. So in this case, if we're talking about intersecting lengths, remember the last video, those equations were intersecting for angles. If we are dealing with tangents, then we say that the segments are equal distance. If we talk about chords, then we say that the product of the segments are equal, or put mathematically, AC will equal BD. And finally, if we talk about secants, you talk about the product of outer segment with total segment. Or again, if we look at how we had that labeled, that was A times A plus B is equal to C times C plus D. That is everything I've got for circles, and hopefully that's enough to get you started on them. Good luck tomorrow. Hope you do well.